müzik dinleteceğim. Alo. Tamam. Söylüyorsun böyle daha iyi bence baksana.
Guys, you hear me? All right, guys. I have Elena, I think Galaxy 8. With Galaxy S8. Elena, you hear me? All right. Kidus, you're here. You guys hear me? Yelena? Yes, I think you hear. Problem is here, so Kudus is here, Yelena is here, Galaxy 80 is Hanos, I think. Alright. If you are ready, we can start. You can wait just a few minutes for the others too. How are you guys doing? You can speak. All right, Kidus, how are you? Anos, you can't hear anything. I don't know what is the problem. So you can check your microphone. Maybe okay. So we start. We can start. Or just let's wait for how many minutes? 4 minutes. After 4 minutes, we can start. Okay. You guys can talk too. All right. You can talk, or you can just text over here. Let me see. So. Yeah. Alrighty. So, you hear me? All right, good. I got Hanos.
I can hear you.
You got it? You can come up. All right, Hanos, you got it? Good. You can start it if you're ready. Delina, Ayubel, what are they? What are they? Delina.
Trying to start with people. You know, a lot of people watch it before. They scrub it up and down. The place for the good. A lot of people, they're after
Right.
dirty and stinky. You don't like it. I don't like it. No one likes it. It's not good. You just follow your own.
Hanos, open up your mic. Unmute your mic.
Working now. It's working.
Right. It's working, right? Good. Okay.
Yeah.
What's happening? What is Ayubel? Bobby was here. He gone. All right, we can start. You can record it and you can share with your friends, okay? If it's possible. All right. If you have any question, you can just ask.
Okay.
Don't like hesitate to ask any questions. It is all right. Okay. So let's begin. You can begin. All right.
Yep.
All right. So our topic is simple machine. So this is
Yeah.
fifth chapter. Simple machines. So first of all, what is simple machines? Let's give a simple definition of simple machine. You know, simple machines, the machine that we use in our daily life, like the simple ones. All the machines consist of simple machines. Without simple machines, you cannot say like there are complex machines. For example, if you are going to manufacture a car, what you need first, you need simple machines. So the part of the car, when you like when you check the part of the car, all of them are represent one simple machine. Okay, so in daily life, we use simple machines everywhere, right? Can one of you give me an example of simple machine? I think we studied already, so I'm just revising it.
Scissors.
Scissors, good. Now, what kind of simple machine scissor is? Can you
Yes.
like lever, you can say, or you can say screw, you can say gear, you can say pulley. Like we have six types of simple machine, right? So one of them, scissor, is like
Yeah.
one of them. This is one of like when you classify the scissors, you are going to put the scissors into which category? What kind of simple machine is scissor? Can you identify or? All right, scissor.
Lever.
We're gonna come there. Okay, we're gonna come there, and let's not make it faster. But yeah, scissor is a simple machines we use in our daily lives. It is very important too, right? So again, we said like simple machines as device is specifically designed or engineered to help make our job easier, right? Our job means our mechanical work. How do you find the work? Let's remember from previous, like we find the work by using force times displacement, right? This is the formula over here.
Yeah.
This is force times displacement. So the SI unit of work was what? Joule. And the SI unit of force is Newton, and SI unit of displacement or distance, we're going to call it meter. So basically, Newton meter will give us Joule. Get this, it's important, okay? So, a simple machine, what does a simple machine do? There are three important tasks that a simple machine does. The first one is the increasing the magnitude of the applied force. Okay, it increases the magnitude of applied force. What is magnitude? Do you guys know? For example, Hidu, what is magnitude? Can you tell us?
The force.
Yeah, the magnitude. Here, magnitude.
The magnitude is the force.
Yeah, you can say the force, but what is the exact definition of the magnitude? Like, can you give the definition of
The number.
the number? Good. The size. Okay. The size is called the magnitude. So when you increase the applied force, the size of the applied force, that means you are going to this is a task of a simple machine. When you use a simple machine, you are going to increase the size of the magnitude here, the size of applied force. Okay. This is the first one. The second one, changing the direction of the applied force or transferring an applied force from one place to another. What kind of example you can give to this explanation, changing direction of the force? For example, in the morning we do like a morning ceremony, like assembly, right? And in the primary part there is flag ceremony, right? Over there, one student, when they pull down the rod over there, what happens to the flag? It goes
It
up.
goes up.
Yeah. This is how you change the direction of a force by in simple machines. So what kind of simple machines are there? What do we have in the like pole? What do we have? Do you guys know? There is a pulley over there. There is a pulley. So when you apply the force downward, it is going to change the direction of the load and it's going to pull up the load. Okay? The force that you apply is called what? Do you know? Do you guys know? The force that you guys apply? So let me choose one here. For example, Delina, you there? Open up your mic. You can answer the question. All right. So, the force that we applied actually is called effort. Okay. The force that we applied is called effort. The force applied by machine is called what? Load. Okay. So the third one, increasing the distance moved against the applied force. Here, increasing the distance moved against the applied force. What does this mean? where does this happen? Increasing the distance. So, for example, let's say you ride a bicycle. When you ride a bicycle, you apply force on the bicycle, right? When you apply the pedals, like when you apply the force too much on the pedals, what's going to happen to you? You are going to go faster. So in this way, you are going to increase the distance, move against the applied force. The more force you apply, the more distance you are going to cover. Okay? Got it? Any questions so far?
Yeah. No.
Okay. The other important thing about the machines cannot create energy. Okay? Machines cannot create energy. Why? What is the reason? Why machine cannot create energy? Remember that according to the law of conservation of energy, energy cannot be created or
Energy can either be created or destroyed.
destroyed. So that's why a machine cannot create an energy. But what can a machine do? It can transfer energy from one place to another one. Okay. So there is going to be energy conversion. For example, when you run, what happens to you? Let's say at the beginning, like you don't do anything, but then you start running. Your potential energy converts into kinetic energy, right? When you start running. So the same thing happens in the machine. When they start moving, the energy over there converts to what kind of energy that you're using. The energy conversion will happen, but you are not going to get an energy over there. Okay? So no machine can create an extra energy. Don't forget this. This is important. Okay. Let's move on. Next we have effort again.
Okay.
Effort. The effort, the force applied by you guys. When you carry something, you apply force on that thing. Okay. For example, let's say you are carrying a box. When you carry a box, you are going to pick it up the box and you are going to move the box. We call this effort. Okay. How do effort means work input, input work that you put inside of the box. How do you find it? We multiply effort, that means a force, effort means force, times distance moved by effort. Okay, effort times distance moved by effort. This is going to be our work input. On the other hand, we have work output that is called load. What does load mean? Load means like, let's say you are driving a box, you are pushing a box, you put effort on it, and the box is going to move in the direction of the force. We are going to put that load. Okay. How do you find load? We are going to work output. How do you find it? We are going to multiply load is going to be our output force times distance moved by load. Here there are two examples I will show you. The first example, when you apply the effort on a box, the box will move. Work input. Here in the second one, second example, as you see, when you apply the effort on the box, you're going to see the box is going to displace in the other direction. So the load will be displayed. We are going to call this part work output. This part will be work input. Okay? If there is no energy load, what's going to happen? Then the work input will be equal to work output. Okay? If there is no energy loss, work input is always equal to work output. So, what does this mean? Effort time distance moved by effort will be equal to times distance moved by load. All right? Any questions so far?
No.
We are here. Let me see. 5 minutes. Okay. You can like, yeah, you can unmute your mic. If you have any questions, just ask. Okay. When I ask you a question, don't
Yes.
answer. It's okay. No problem. All right. All right. Let's move on then. Next, what we have? We have a question over here. We have a question. Let's pass this part. For example, imagine a machine that when an effort of 100 newtons moves 2 meters. When you say effort, this is your effort is moved by effort 2 meter, okay? A load through a distance of 0.5 meter. And this one will be 0.5 meter will be the distance moved by load. Okay, so we can determine the maximum value of the load. So what was our formula? Let's go a little bit back. So effort times distance moved by effort will be load times distance moved by load. And then here, our effort is 100 Newton, and the distance moved by effort is 2 meter. 100 times 2 equal to load times, since you are looking for load times 0.5 meter, the distance moved by load. Okay, so here 100 times 2, 200, and then divided by 0.5, you're going to get load 400 Newton. Okay, don't forget it. Load and effort are both of them considered as forces. Got it? Both of them are forces. That's why they have the same SI unit as force. Got it? One of them force input,
Yeah.
the other one is force output. Force output is our load, force input is our effort. Okay? Let's move on.
Yeah.
So let's, from this whole explanation, let's define the simple machines. We can get three simple definitions here. A device that only requires a single force to work. For example, when you get the screw, what do you need it? When you use a screw, what do you need it? You just need to take the screw and like use your hand. Your hand will be enough to that force in your hand will be enough to move the screw. The second one, a device for doing work that has only one part, one movable part. It should be just one movable part. If there are more than one movable part, that is not going to be considered as simple machine. Okay? This is important. Has only one movable part. The other one, a device that uses a single effort to do work against a single load force. A device uses a single effort. For example, when you use the pulley, what do? You just pull down, you just pull down the rod and the load will go up. So you just need a single effort, single force to work against a single load force, right? These are the three basic explanation for simple machines. So again, they are elementary building blocks from which all other machines are made. When you make car, you have to use simple machines. When you, let's say, when you assemble a rocket, you have to use simple machines. Okay? Whatever you do, you need simple machines. Whatever you want to create or produce, you have to use simple machines to create that devices or that stuff. Okay? So we have 6 different types of simple machines, right? Inclined plane, lever, wedge, screw, run axle, and pulley. These are the 6 types of the simple machines. You guys should like do this like you know your name, okay? When I ask you like how many types of simple machines you have, you guys should say 6 types of the simple machines and should be able to name them, okay? I am planning to give you a quiz by Friday, okay? By Friday about this topic actually, about the topic that we just do revision.
Okay.
We're gonna have a quiz, so be ready for that too. Okay. So let's just move on. How many minutes pass? I don't know. We have just I think 7 minutes. This is a lever. Okay. This is a lever, as you see over here. This is a pulley. Pull down. Change the direction of the object. Don't forget it. This is an inclined plane. Okay. It is force multiplier. Inclined plane is a force multiplier. Uh, Example for the inclined plane, you know, in our high school, next to the stairs, there is a ramp. That ramp is called an inclined plane. Okay. When you walk on that ramp, you are going to use less energy. Okay. When you use that ramp, instead of a stairs, when you use the ramp, you are going to have oh, 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 this one, okay. So when you use that ramp, you are going to do what? You are going to use less energy, right? Screw, you know already, screw is a screw over here. A wedge, well, why do you use the wedge? Generally, when you like cut the logs, when you cut the wood, you put the wedge over there, or when you like, you can stop the cars by using wedge. When you put the behind the tires and stop them. And this one is wheel and axle. These are the 6 types of the machines. So we call that machines are called like force multipliers, distance multipliers, direction changers, and speed multipliers. So how are we going to classify? So force multipliers over here, the load is greater than the effort. When the load is greater than effort, we are going to say that this machine is a force multiplier. When the load is greater than the effort, don't forget it. This part is important. Load is greater than the effort, so you're going to say that this machine then is a force multiplier. Okay. The second one is speed multiplier. This time the distance moved by load is going to be greater than the distance moved by effort. Distance. This is depending on the distance. Distance moved by the load will be greater than distance moved by effort. Okay. These machines are called speed multipliers. If the distance moved by a load is not greater than the distance moved by the effort, then we are going to do this machine's direction. Okay? If the distance moved by effort is smaller than here, if the distance moved by load is greater than the distance moved by effort, this is going to be speed multiplier. If the distance moved by load is smaller than the distance moved by effort, that time you're going to call those machines direction changes. Okay? So let me give you an example for direction changes for simple machine. For this one, direction changes you can call pulley. Okay? Pulley. Pulley is a direction changer. When we go to the force multipliers here, force multiplier, the load is greater than the effort, then you can say inclined plane. Okay? Example force multipliers, you can say an inclined plane. The load is greater than the effort. Okay? You don't need to spend more force in order to carry a load. Got it? These are called force multipliers. For speed multipliers, you can see a screw. Okay? The load is greater than the distance moved by load is greater than distance moved by the effort. Okay? The screw is an example of speed multiplier. All right? Any questions? Everyone's okay? I think there's no questions. So good. So let's move on then. Mechanical advantage and velocity ratio. Let's just explain this part. You can break quickly. So mechanical advantage. What does mechanical advantage means? What does velocity ratio mean? These are the two terms that we use to define the machines, the efficiency of a machine. What does efficiency mean? Efficiency means how well a machine can work. Okay? How well a machine can work. We call this efficiency. So in order to define the efficiency, you need mechanical advantage and velocity ratio. These two terms are important. Okay? So let's say some machines are more effective than others. Okay, let's move on over here. So, here, mechanical advantage, the ratio between load and effort. The ratio between load and effort is called mechanical advantage. It doesn't have any unit. Mechanical advantage, velocity ratio, and efficiency. These three terms are, they do not have, guys, don't use anything. Don't. Those three things do not have any unit. Velocity ratio, and efficiency. As you see here, mechanical advantage means load over effort. Load has a unit of Newton, effort has unit of Newton. When you divide Newton to Newton, you are going to have 1. So that means mechanical advantage do not have any unit. Okay? It doesn't have any. Mechanical advantage, when the effort equals to load, that means the mechanical advantage will be 1. Okay, when the effort equal to load, mechanical advantage will be 1. When the load is greater than the effort, the mechanical advantage will be more than 1. And when effort is greater than the load, the mechanical advantage will be smaller than 1. Don't forget this. Okay, okay, we have 10 minutes, guys. Just 10 minutes. We have two types of mechanical advantage. The first one is actual mechanical advantage. The second one is ideal mechanical advantage. Again, the ratio between load and effort. There is going to be energy loss for the actual mechanical advantage due to friction. Due to friction, there is going to be energy loss. But ideal mechanical advantage, there is no energy loss. Okay? If there is no energy loss, we call that kind of mechanical advantage ideal mechanical advantage. No energy loss. If there is energy loss, we call that mechanical advantage actual mechanical advantage. Okay? Actual. And when there is no energy loss, we are going to also say ideal mechanical advantage will be equal to velocity ratio over here. Velocity ratio means the distance moved by effort over distance moved by load. The ratio of distance moved by effort over distance moved by load. Okay? This is called velocity. Again, when there is no energy loss, mechanical advantage will be equal to velocity ratio. Don't forget this. If there is no friction, that means there is not going to be energy loss. And that means velocity ratio will be equal to mechanical advantage. Okay? So, this is possible in mechanical and velocity ratio can be equal. Is this possible? Is it possible mechanical advantage and velocity ratio can be equal in the world? What do you guys think? Right. It is not possible actually. Why? Because wherever you go, there is friction. Since there is friction, this friction will cause an energy loss. When there is energy loss, the mechanical advantage will not be equal to velocity ratio. Okay, so that's why you can make a machine like 99% efficient, but you cannot make a machine 100% efficient. Okay, a machine cannot be 100% efficient due to friction. Okay, when you create, for example, let's say the cars that you use get broken down easily, right? Like after some time they get broken down. The reason is because of the mechanical advantage. Because their mechanical advantage and velocity ratio are not the same. Because there is friction, and due to friction, the friction causes like the car wear down easily, and then the car gets broken down. Okay? These are the reasons. So when there is, well, like when there is, let's say, there is no friction, which is not possible in the earth, in the world, we are going to say that velocity ratio and mechanical advantage are. So next we have efficiency. Again, efficiency means work output over work input. It doesn't have any unit like mechanical advantage and velocity ratio. When you like check the work output means joule. Work input also has a SI unit of joule. When you divided them, again you are going to get. So in here it does not have any. Okay? So what does it, this ladder now, it's a Greek ladder which we show the efficiency. So let's see here there is an example that the machine is 80%. When it's 0.8, it means 80%. When there is 0.4, that means 40%. When there is 0.2, that means this means that you would get 80 joules of work output in 80 joules for every 100 joules put in. Like work input. Your work output is 80 joule, 100 joule. That means we are going to have 80% machine. Put 500 joule input work, you would get 400 joule output work. You can multiply it by 500 by 5, it's going to be 400. Okay? So here, all right, let's stop here. Let me ask you questions. Do you guys have any questions so far? Let's stop here. Efficiency of the machine. All right, just remember, a simple machine means it should have only one movable part. Okay, one movable part. It doesn't. It is applicable to all other machines. Complex. Without simple machines, we cannot have complex machines. Okay, this is important. The other thing about simple machines, you should remember, they are force multipliers, they are speed multipliers, and they are direction changes. Okay, a simple machines can change direction of the object, can speed up the object, and can change the distance of the object. Don't forget the other three other important things. Velocity ratio, mechanical advantage are important too. Velocity ratio means distance by effort over distance moved by load. Mechanical advantage means load over effort. Don't forget this. When you go to the efficiency, efficiency means work output over work input. Work output comes from load, work input comes from effort. Okay? What does effort mean? Effort means the force that you guys apply on a machine. Okay? For example, when you ride a bicycle, your legs are like your feet are applying force on the pedals. Okay? This is called effort. And when the bicycle starts moving, called work output. Okay? When work input equal to work output, that means there is no energy loss. Okay? Work output, that means no energy loss. And when these two are equal, that means mechanical advantage and velocity ratio are the same as well. Right? Yes, Ikram. Go ahead. Ikram, raise his hand. Ikram. You wanna talk? Go ahead. Ikram? Let me lower your hand. Oops. Okay. All right, guys. Any questions? You can turn on. You can turn mics. Turn them on. You guys have any questions so far?
I have a question.
Yes, go ahead.
Miss,
Yes, Kidus. Go ahead.
you said a simple machine only have one movable part, right?
Yes, it has only one movable part.
And a scissor. It has two
What do you say?
movable parts.
Can you repeat? I couldn't hear you. Or you can write over here. Like,
A scissor.
a scissor, yes. A scissor has one movable part. You know what? Which part? The screw part in the scissor. The scissor, that part is only movable. Not your fingers are moving, yes, but your finger are moving the other two parts, okay? But the movable part only there. Here, let me show you the lever. Let me show you the lever here. Like, let me do that. So here is lever. You see here? Lever? So the scissor has one point over here. That point is movable, okay? This one is not movable. Okay? So scissor has only one part which is movable. Here, this one. Right? So that part, when they are not moving. They are not moving. The only movable part of the scissor is here.
Okay.
All right. Any questions? Other questions that you guys have? You don't have it? We have